In this video, we're going to be focusing on the log laws and the change of base formula. In calculus in particular, there are three log laws that you need to know. For any base c, log to the base c of ab is equal to log to the base c of a plus log to the base c of b. Log to the base c of a divided by b is equal to log to the base c of a minus log to the base c of b. And log to the base c of a to the power of m is equal to m times log to the base c of a, so that power m can come down. There's also the change of base formula, so if you have some log expression with base c, you can change it to have any base you want. So this b can be chosen to be anything you want, so that log to the base c of a can be equal to log to the base b of a divided by log to the base b of c. This c is the old base. And like I said, this b can be chosen to be anything you want. Now, there's also a natural log representation of each of these. All these laws apply to the natural log as well. The natural log is just log in particular with base e, but it can look a little different, so I'll rewrite the laws using natural logs as well. So the laws are natural log of ab is natural log of a plus natural log of b. Natural log of a divided by b, that's equal to natural log of a minus natural log of b. And natural log of a to the power of m, that's m times natural log of a. So these are the very same rules as the one above, just written using natural log instead of log to the base c. And if you wanted to change log to the base c of a to an expression where the base is e, or to natural logs, well, that would work the same. Log to the base e of a, which is natural log of a, divided by log to the base e of c, which is natural log of c, the old base. One thing to make sure to note is that these are the only log laws you have. There are no log laws for expressions such as log of a plus b or log of a minus b. There's nothing for log of a times log of b, and there's nothing for log of a divided by log of b. There are no formulas to change these representations, so don't try to do anything with expressions that look like this. These laws only apply to expressions like this. Okay, so let's take a look at a couple of examples just to try to see how these things are applied. Suppose the goal here is to apply all of the log laws in sequence to this expression here. Well, first of all, what we can do is we can change the x squared y over z. We can treat that as a over b, and then natural log of a over b is natural log of a minus natural log of b. So that's the first thing that we can do. Next, we notice that we have two things multiplying here, so it's kind of like log of ab. So applying that first law from the previous page, we can change that to natural log of x squared plus natural log of y, and the minus natural log of z is still there. And then finally this power of 2 can come down. So that's how you would apply the log laws to an expression like this, and that can be an important thing to do in calculus, because applying some of the calculus techniques to this expression can be very hard, but after you've applied the log laws, it gets a lot easier in a form like this. And the change of base formula, so the base we change to can be any base of our choosing. So for example, if we wish to change this to base 3, this is what we would get. So it's log to the base 3 of x divided by log to the base 3 of the old base, which was 2. Suppose we wanted to change the log to base 7, so it becomes log to the base 7 of x divided by log to the base 7 of that old base. Or even if we wanted it in natural logs instead, it would be natural log of x divided by natural log of 2. So this new base that we choose can be anything we want.